We'll talk about IP addressing and subnetting. We'll also talk about VLSM. So this is one thing that is the primary focus. And then we'll talk about the network devices. What all are those? And how they behave. Similarly, we'll talk about how data communication happens using your IP addressing scheme. How does ARP happens? We'll discuss all those data communication expect at a very basic level. We'll see how two PCs or two devices sitting in a network, they can exchange the data. All right. So what we'll do is let's start with IP addressing and subnetting concept in the first half, and then we discuss the next thing later. So if I look into my slides over here, with respect to IPv4 addressing, we'll talk about what is an IPv4 address. How do you represent it? How do you write it? What is the relationship with binary and decimal number? Because when you learn IPv4 addressing stuff, you should know the binary addressing scheme, the conversion between binary to decimal to binary, a bit of maths involved into that, and we'll talk about the v4 address and subnet mask, how to calculate those stuff. Okay. Following this, we'll talk about the v4 subnetting stuff. So I'll use whiteboard to discuss v4 address, and let's learn it. Okay. All right. So when you talk about IPv4 addresses, so so any device, when you talk about IPv4 address, first of all, we have got 5 classes, right? So this 5 classes, this IPv4 addressing concept was given to us by IEEE. So IEEE manages the concept of IPv4 addressing and the regulations of it, right? So IEEE has given the concept of IPv4 addresses and the respective classes and how they will operate in your network. So we've got 5 classes over here. So the classes we represent like that. We have got class A, and every class has got a range of numbers. Okay, that range of numbers is between 0 to 256. Okay, so that is how it goes for class A. The range of numbers that has been defined is 0 to 127. For class B, the range of number that has been defined is 128 all the way to 191. For class C, the range of number is between 192 to 223. For class D, the range of number is between 224 to 239. And for class E, the range of number is between 240 to 255. So if you count from all the way from 0, it is till 255. So overall it is 256, right? So now what happens here is with respect to this, right? First of all, you should know, before I talk about IPv4 address and discuss how to assign an IPv4 address and talk about the respective classes, etc., etc. First, we'll talk about a decimal to binary conversion. Okay, and then we'll talk about the opposite, which is a binary to decimal conversion. Right. So first, we talk about decimal to binary. In that regards, if I give you any decimal number, say I give you a number as 64, right? 64 being a decimal number. Now, if I need to convert that number into binary, right? So if I say that convert this 64 into binary representation. So normally what we do is, let me take out my pen. So what we usually do is we take this number 64, right? And then to get the respective binary, we actually divide this number with a factor of 2, right? So we take the value 2, so 2 divisible by 32, the carry or the remainder is 0. Then we take the factor 2 again, we divide it by 2, so it is 16, the remainder is 0. It is divisible, the value is 8, the remainder is 0. Divisible by 4, remainder is 0. Divisible by 2, remainder is again 0. And then it is divisible by 1, and the remainder is 0. Now you take the values from, these are your basically binary numbers, what you got, and you take it from your bottom to top. So it's 1 followed by 1, 2, 3, 4, 5, 6 zeros. So this means, the value 64 in decimal is equivalent to 1 followed by 1, 2, 3, 4, 5, 6. So overall, I've got 7 bits over here, right? Total is like 7 bits. Now, if I want to represent, this is giving me 7-bit number, right? So if I need to represent this into 8 bits, if I need to convert that into 8 bits, so what I'll do is I will add a 0 in the prefix. All right. So to convert that into 8 bits, if I need to convert that into 8 bits, normally what I do is we write a 0 before this number. So 0 followed by 1 followed by 4, 5, 6, 6 zeros. So that overall it is your 8-bit representation of the decimal number 64, right? Similarly, if you want to convert, any number, like for example, you take the value 128, right, as a decimal number, and if you need to convert that into a binary number, so it will be 1 followed by 7 zeros, 1, 2, 3, 4, 5, 6, 7. If you follow this method or the other way around, the same thing will get this value. So here we are getting this into 8 bits itself, right? So any number you take, either you can approach this method, divide that number by a factor of 2, and whatever values you get, you take it from bottom to top, you get the respective binary of it. All right. Other way around is another simple technique I'll tell you. So what you write down is you write down the 8 bits. For example, let's say we have the 8 bits representation right from, let us say, right to left. So it is like 2 raised to 0, then 2 raised to 1, 2 raised to 2, 2 raised to 3, 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7, right? So these are basically my 8-bit position values. Okay. So accordingly, if I get the, respective answers, 2 raised to 7 is basically your 128. This is 64. This is 32. This is 16. This is 8, 4, 2, and anything to the power of 0 is 1. All right. These are basically your, bit position values, right? So I've got 8 bits. These are my different 8-bit position values that I have. Now, for example, I got a number which is say 192. Okay, this is a decimal number. And let us say I want to convert that decimal number. This is my decimal number. I want to convert that into a binary, right? The question is, please convert that into binary. So you can do what? You can actually find out the combination of these values and find out which combination would give you the number 192. So always while doing this, go from your left towards your right. Okay, so 192 means if I add 128 and if I add this value 64 together, the answer is 192. So I can keep this bit position values as 1. Okay, and the remaining bit position values I can keep it as zeros, right? So this is giving me the value which is 192. All right. So the answer is 11 followed by 6 zeros. Okay. Similarly, if I take a value, say example, 224, same thing. That's my decimal number. I want to convert that into the respective binary. So you know that if you add 128, 64, 32, if you add these 3 values together, you'll get the answer is 224. So it will be like, 111 followed by 5 zeros. All right. So the answer is 111 followed by 5 zeros, 3, 4, 5. Okay. So I'll want to give you the exact values that you normally get. So the first value, which is very, very commonly used, that I'll say you. So the first value would be 128. Okay. Next value in 8-bit position, I'm saying you 128. 128. The binary of 128 will be 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. Then we have got the value which is 192, right? Which is 11 followed by 6 zeros. The next value will be 224, which is 111 followed by 5 zeros. Next is your 240, which is 4 ones and 4 zeros. Next is your 248, which is 5 ones, 4 zeros. 248, which is 4 ones, 4 zeros. Next is your 249, which is 5 ones, 4 zeros. Next is your 250, which is 4 ones, 4 zeros. Next is your 251, which is 5 ones, 4 zeros. Next is your 252, which is 5 ones, followed by 3 zeros. The next is your 252, which is basically 6 ones, followed by 2 zeros. Next is your 254, which is basically 7 ones with a single zero. And the last value is 255, where all the bit values would be high. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And the value, if it is 0, for example, that means all the values would be 0. Right? So basically the common combinations that we have, right? Or in the middle, if you want to have any combinations, for example, if you get a value like 48, right? So basically 32 plus 16 is 48. That means what will happen if the decimal number is 48, then you find out the combination, from right to left, go towards right to left and find out which combinations will give you the value 48. So 32 plus 16 is 48. So the rest everything would be 0. Only 32 and the 16-bit position would be high. The rest everything would be 0. Right? So like that, you have to find it out. Okay. On the other way around, if I give you, the opposite, say I give you a binary number and then I tell you to convert that back into a decimal number. It is also a simple thing. So let me, write down that as well. So if I give you a binary number, let's say, so similarly, if I give you a binary number, so it is binary to decimal conversion, right? Very, very simple things. So if I give you a number like, for example, 111 followed by 5 zeros, 1, 2, 3, 4, 5, right? And if I ask you that what is the uh, equivalent decimal number for this binary, again you get the same logic. So you place the decimal bit position values. So you place 128, 64, 32, 16, 8, 4, 2, 1, and you write down this binary on the respective bit position values. So it's 111 followed by 5 zeros. So we sum up the respective values for whose bit values are 1. So 128 plus 64 plus 32, when you add those three values, the answer is 224. Right? So this gives you the value or the answer is 224. Right? Now, any combination that you get in your examples, for example, if I write down, I've got a value 10101010, right? Like that. A binary number is given to me. What is the respective decimal for that? This is binary. What's the decimal for that? So write down the bit position value as 10101010, right? So you get the answer as 128 plus 32 plus 8 plus 2, right? So this is 20. So 3, 5, 6, 7. So it is like 170. So the answer that you get is 170. Right? So similar concept. So if you take out any binary number, just place that into the respective bit position values, and you add those values, which is on the higher side. Just add the high bit values, you get the respective decimal number. Okay. Now there are other conversions also. Binary to hexadecimal conversion, hex to binary, all those stuff. Later down the line when you go to CCNA, those conversions are important. But as of now, I'm okay with this. Right? For the pre-CCNA level, if you know at least this, it is quite okay.